MES College Marampally, e-learning.
Nasreen A, Assistant Professor, Department of Mathematics, MES College Marampally. Here I am going to give a small introduction to linear transformation and how a matrix is formed from a linear transformation.
What is a linear transformation? Let us define. Let U and V be two vector spaces over the field F. A mapping T from U to V is a linear transformation if it satisfies the following two conditions. First one is T of U plus V is equal to T of U plus T of V for all U comma V belongs to U, and T of C U is equal to C into T of U for C belongs to the field F. Let us go through an example. Let T from R square to R square defined by T of x1 x2 is equal to ordered pair x1 plus x2 comma 3x1. Let us check whether it is a linear transformation or not. Before checking this, let us see how addition is defined in the vector space R square. Take two elements, ordered pair x1 x2 and ordered pair y1 y2. How addition is defined between these two elements? It is nothing but the coordinate wise addition. That is, ordered pair x1 x2 plus ordered pair y1 y2 is equal to ordered pair x1 plus y1 x2 plus y2. And the scalar multiplication is defined as C into ordered pair x1 x2 is equal to ordered pair C x1 C x2. Now we will verify the first condition of the linear transformation, that is T of ordered pair x1 x2 plus ordered pair y1 y2 is equal to T of x1 plus y1 x2 plus y2. This is equal to, the mapping is T of x1 x2 maps to x1 plus x2 comma 3x1. Therefore T of x1 plus y1 comma x2 plus y2 maps to x1 plus y1 plus x2 plus y2 comma 3 times the first coordinate, that is 3 into x1 plus y1. This is equal to, let us rearrange it, that is x1 plus x2 plus y1 plus y2, and here we open the bracket 3x1 3y1. This is equal to, we can split this into two coordinates, that is x1 plus x2 comma 3x1 plus y1 plus y2 comma 3y1. This is equal to T of x1 comma x2 plus the second one is T of y1 comma y2. The first condition of the linear transformation is verified, and the second condition is T of C into x1 comma x2. This is equal to T into, scalar multiplication is defined as Cx1 Cx2. This is equal to, the first coordinate is Cx1 plus Cx2, the addition of the first two coordinates, and the second coordinate is 3 times the first coordinate, that is 3c x1. This also can be written as c x1 c into x1 plus x2 comma 3x1. This is equal to c into t of x1 comma x2. That is t into c of x1 x2 is equal to c into t of x1 comma x2. Therefore, the first two conditions of the linear transformation are satisfied, and therefore our transformation t of x1 x2 is equal to x1 plus x2 comma 3x1 is a linear transformation. Let us go through another example. Let t from r cube to r cube defined by t of x1, x2, x3 equal to x1 plus 1, x2 plus 1, x3 plus 1. We have to check whether it is a linear transformation or not. We know that R cube is a vector space, and addition between the elements in R cube is defined as order triplet x1, x2, x3 plus order triplet y1, y2, y3 is equal to order triplet x1, y1, comma x2 plus y2, comma x3 plus y3. And the scalar multiplication is defined as c into order triplet x1, x2, x3 is equal to order triplet cx1, cx2, cx3. We have to verify that T is a linear transformation. The first condition we have to check. For the checking the first condition, we just take the two elements x1, x2, x3, comma y1, y2, y3 from R cube. T of x1, x2, x3 plus order triplet y1, y2, y3 is equal to T of, the addition is defined as order triplet x1 plus y1, x2 plus y2, x3 plus y3. The map is T of x1, x2, x3 is x1 plus 1, x2 plus 1, x3 plus 1. The first coordinate maps to plus 1, the first coordinate. Similarly, the second coordinate and the third coordinate. Therefore, this is equal to x1 plus y1 plus 1, x2 plus y2 plus 1 and x3 plus y3 plus 1. This is equal to order triplet x1, x2, x3 plus order triplet y1, y2, y3 plus order triplet 1, 1, 1. And this is not equal to T of x1, x2, x3 plus T of y1, y2, y3. Therefore, the first condition of linear transformation is not satisfied. We need not check the second condition of the transformation. Therefore, if the first condition itself is failed in this mapping, therefore this is not a linear transformation. Next, we will see how a matrix is formed from a linear transformation. Before that, let us go through a theorem. Let T from R raised to n to R raised to m be a linear transformation. Then the theorem says that then there exists a unique matrix capital A such that T of x is equal to Ax for all x belongs to R raised to n. Here A is the matrix. A is equal to T of E1, T of E2, etc. T of EJ. That is, this is the matrix whose jth column is T of EJ. Here E1, E2, etc. En is nothing but the standard basis of R raised to n. We know that R raised to n is a vector space and it is of dimension n. Therefore, the basis elements contains n elements. Here we take the standard basis E1, E2, etc. En. Move on to the example. Let T from R cubed to R raised to 4 defined by T of x1, x2, x3 is equal to x2 plus x3, x3 plus x1, x1 plus x2, x1 plus x2 plus x3. We will check how a matrix is formed from this linear transformation. Here R cube is a vector space. We want to know what is the standard basis of R cube. The standard basis of R cube is order triplet 1 0 0 0 1 0 and 0 0 1. This is the standard basis of R cube. Before writing the matrix, we should know about the basis of the vector space. We defined the matrix of the transformation T is written as T of E1, T of E2, etc. Where E1, E2 is the standard basis of R raised to n. Here there are only 3 elements in the standard basis. Therefore, E is written as T of E1, T of E2, T of E3. Now we are going to find out what is T of E1. That is equal to T of 1, 0, 0. This is defined as T of x1, x2, x3 is defined as x2 plus x3, x3 plus x1, x1 plus x2 and x1 plus x2 plus x3. Therefore, the first element is the addition of the second and the third element, that is 0 plus 0. And the second element is 0 plus 1, 1 plus 0, 1 plus 0 plus 0 and this is equal to 0, 1, 1, 1. This belongs to R raised to 4. Next, similarly, we find T of E2. What is T of E2? T of 0, 1, 0. That is equal to 1 plus 0, 0 plus 0, 0 plus 1, 0 plus 1 plus 0. This is equal to 1, 0, 1, 1. T of E3. This is equal to T of 0, 0, 1. This is equal to 0 plus 1, 0 plus 1, 0 plus 0, 0 plus 0 plus 1. This is equal to 1, 1, 0, 1. Therefore, the matrix of the linear transformation T is written as the first column is T of E1, that is 0, 1, 1, 1. Write it vertically. And the second column is 1, 0, 1, 1. And the third column is 1, 1, 0, 1. This is the matrix of the linear transformation. And by examining it, we know that this is a matrix of order 4 by 3. This is a 4 by 3 matrix. That is, when we write the matrix of a linear transformation from R cubed to R raised to 4, we get a matrix of order 4 by 3. In general, if we are writing a matrix of a linear transformation from R raised to n to R raised to m, we will get a matrix of order m by n.
Using this method, we can write matrix of any linear transformations. Thank you.